In this video, we'll be going over the bottom-up 2D matrix approach of distinct subsequences. Let's go over the thought process. So let's convert the top-down memorization approach to a bottom-up approach. Now, where do we start? In the memorization approach, we have cached I and j with the number of subsequences. This means we can create a 2D matrix, subsequences, to keep track of the number of subsequences for all combinations of I and j. Now, what are the default values inside the subsequences matrix? When j is out of bound, we have successfully found all the characters inside T, so the number of subsequences will be equal to 1. Now, when I is out of bound, j is the pointer currently inside T, so it's the pointer inside T, and then I is pointer inside S. And then when I is out of bound, this means we have failed to find a subsequence, so the number of subsequences will be equal to 0. Now let's go over the pseudocode. So I'm going to create a 2D matrix, subsequences, to keep track of the subsequences for all combination of I and j. Then we're going to iterate through the indices from s dot length to 0, which would denote it as I, and then we'll iterate through the indices from t dot length to 0, denoted as j. Now, if j is out of bound, which is equal to t dot length, then we have found one possible subsequence. So we set subsequences I and j to 1. Then we can continue to the next iteration. Then if I is out of bound, this means we have failed to find a subsequence. We can just continue to the next iteration because the matrix has a default value of 0, so we do not need to set 0 again. Now, we first want to find the number of distinct subsequences if we just skip the current character inside S, which basically moving our I to I plus 1. So we're going to increment the current number of subsequences by the number of subsequences if we move I forward by 1. Basically skipping the current character inside S. Now, if the character at index I inside S is equal to the character at index j inside T, this means we can check the number of subsequences by moving both pointers forward. So we can increment subsequences by the number of subsequences if we move pointers forward. Then we can return the number of subsequences if both pointers starts at index 0. Let's go over to time and space complexity. So the time complexity of m times n, where mn are the length of the two input strings. This is the nested for loop. Nested for loops. And our space complexity is also of m times n. This because of the subsequence matrix. Now let's go over the code. So we're first going to create our subsequences matrix. Then we're going to iterate all of the indices from s dot length to 0, denoted as I. And then we iterate all of the indices from t dot length to 0, denoted as j. Now, if j is out of bound, this means we have found one possible distinct subsequence. So I'm going to set the current number of subsequences to 1. Then we continue to the next iteration. Then if I is out of bound, this means we'll fail to find a subsequence, so we can just continue to the next iteration. We have a default value of 0 anyways. Now we first want to increment by the number of subsequences if we move I forward, basically skipping the current character inside S. Now we want to check if the current characters at the two indices are the same. If they are both the same, then we can check the number of subsequences if we move both pointers forward. We increment the number of subsequences if we move them both forward. And then we can return subsequences if both pointers start at 0. Let me know if any questions in the comment section below.